Welcome to Math World. Today's class, let us learn about geometrical meaning of the zeros of a polynomial. How do we represent a polynomial in graph? Whether the geometric representation of a polynomial gives any idea about the zeros of a polynomial. That we will learn in today's class. I think you have studied how to represent a polynomial in graph. A simple linear polynomial is given to you. Say suppose y equal to ax plus b. Okay, if this polynomial is given to you, then how do we draw the graph of this? We'll make a table which has x values and y values. Okay, we'll give values to x like -1, 0, 1 like that, and respected y values we write, and we'll take a graph sheet. Along x-axis we give the value, what happens when x is 0, what happens to the value of y, what happens when x is +1, when x is -1. We will plot the points depending on this table and will join the points, right? This basic you know. Now if suppose polynomial say y equal to 2x minus 4. In fact, p of x is my polynomial. It is 2x minus 4. Okay, now I want to draw a graph of this. First I have to make a table. So this is first case I'm taking. Linear polynomial I'm taking. X values and y values. When x is 0, y is -4. When x is -1 into 2, it is -2 and -4, so it is -6. When I give x is 1, 2 minus 4, it is -2. When I give x as 2 into 2, it's 4. 4 minus 4 is 0. If you want, you can continue. -2 minus 4 minus 4, so it is -8. So I got this one such point where y is becoming 0. Okay, y becoming 0 means zeros of the polynomial. I explained about zeros of a polynomial in my last video. So zeros of the polynomials are the x coordinates of the point where the value of the polynomial y becomes 0, right? So we'll try to draw this graph. This is my x-axis, say this is y-axis. Okay, now when x is 0, y is -4. So it comes somewhere here. Okay, -4. 0, 1, 2, -1, say -2, -1, 1, 2, 1, 2, 3, like that. Say -1, -2, -3. Okay, suppose this is the case. And now when x is 0, y is -4, my points is here, and when x is -1, y is -6. Okay, somewhere here. Then x is 1, y is -2, so somewhere here. Now when x is 2, y is 0. When x is -2, it is -8. Okay, somewhere here. Okay, somewhere here. It's okay, no problem. We'll take up only these 4 points. So if I draw it like this, I have to join the points. Okay, comes out to be a straight line. Y equal to 2x minus 4. You observed this. Say in general, when a polynomial y equal to ax plus b is given to you, you are going to get a straight line, either like this, like this, like this, like this, like this, somewhere. Okay, if you are getting a linear polynomial, you will always get a straight line. Okay, in this case also, I have given the polynomial y equal to 2x minus 4 and you are getting a straight line. Where this line is cutting x-axis, it intersects x-axis at this point, right? Here the value of y is y is 0 and x value is 2. So this is nothing but the 0 of the polynomial. You can check it out. See, how do you get the zeros of the polynomial? You equate the polynomial to 0. Then you will simply solve the polynomial. You are getting x equal to 2 as the 0 of the polynomial, right? So here it is becoming 0. So this is the 0 of a polynomial. X equal to 2 is the 0 of the polynomial 2x minus 4. So zeros are the root of a polynomial. The zeros of the polynomials are x coordinates of the point where the graph of the polynomial intersects x-axis. Okay, at this point where the graph of the polynomial intersects x-axis, that point is nothing but the 0 of the polynomial. So in general, a linear polynomial ax plus b, where a is not equal to 0, the graph y equal to ax plus b is a straight line. Graph of y equal to ax plus b is a straight line which intersects x-axis exactly at one point. And that point is minus b by a, 0. Y value becoming 0 and the value of x is nothing but minus b by a. I explained about this in my previous video. Okay, so when you have a linear polynomial, you are getting exactly 1 0. Linear polynomial has got degree 1, therefore you are getting only 1 point where the value of the polynomial is becoming 0. So graph of y equal to ax plus b is a straight line which intersects exactly at one point on x-axis. So zeros of a linear polynomial is only 1. Now we'll go for quadratic polynomial. Suppose, see, when you have a quadratic polynomial, there are 3 cases. Quadratic polynomial, it has got a general representation ax square plus bx plus c. Okay, this is the general representation of a quadratic polynomial, is ax square plus bx plus c. Now when you draw a quadratic polynomial in general, there are 3 cases. Okay, when the graph cuts x-axis at 2 points, then we say that a quadratic polynomial has 2 zeros. and the polynomial, when you draw here, you are getting a straight line. In this case, you are getting a parabola. Okay, three possibilities I'll just tell you. One possibility is like this. You may get a polynomial like this. Okay, upward. This is the case, parabola like this. This is the case where a is positive. Like when you are positive, you will smile. This is one case. The second case is you may get it on x-axis, either side of the y-axis. Okay, like this you are getting. This is the case where a is negative. Means the parabola is intersecting x-axis at 2 points. Here also it is intersecting x-axis at 2 points. So this is the case 1. You have got 2 zeros. Okay. The second case is you may get it like this. Say this is y-axis and x-axis. Something like this you may get. Okay, something like this, either here or here or here, like down like this. You're getting only you're getting 2 points where x-axis it is cutting intersecting x-axis at 2 points. Here also 2 points. Second case is something like this. It will not cut x-axis, something like this. Okay, see here at this point is on y-axis and it will never touch x-axis. So in this case, no zeros. I'll give you example for each case. Okay, and the third case, something like this. When you draw up points, you are going to get a parabola, something like this, Okay, so it's intersecting x-axis exactly at 1 point. So you are saying only 1 0 or 2 zeros are equal. Okay, I'll explain you with an example. 1 0, or you can say that is same as saying 2 equal zeros. Okay, let us look at the problem. Say suppose I have y equal to polynomial y equal to x square minus 4. Here in this case, what is the value of a? General form of a polynomial is p of x equal to ax square plus bx plus c, right? Quadratic polynomial. So in this case, value of a is 1. It is greater than 0. So your polynomial, your graph will look like this. Okay. But where exactly it is situated, that we will have to draw. We'll make a table of x, y values. When x is 0, y value is minus 4. When x is 1, y value is minus 3. When x is minus 1, this is again minus 3. And when x is 2, 2 is a 4, 4 minus 4 is 0. And when x is minus 2, again it is 0. Okay, this much is enough. Now let us go for drawing. Zero, 1, 2, minus 1, minus 2. And I want minus 4, minus 3. Okay, minus 1, minus 2, minus 3, say minus 4. 1, 2, like this. This is x-axis and this is y-axis. Okay. Now when x is 0, value of y is minus 4. So point is here. When x is 1, it is minus 3. And when x is 2, it is 0. When x is minus 1, it is again minus 3. And when x is minus 2, it is 0. So let me join the points. Parabola goes like this. Okay. Here a is greater than 0, so it goes like this. Okay. Now see, look at the graph of this parabola, x square minus 4. It's intersecting x-axis at 2 points, exactly at 2 points. One is minus 2 comma 0, another one is 2 comma 0. So this case it has got 2 zeros, that is minus 2, one value is minus 2, another value is 2. Okay, so I hope you understood this. Now let us take another example. Say y equal to x square plus 4. I'll directly write the table. When x is 0, this is the table for x square plus 4. When you try to draw this, okay, I have taken very few points. See, depending on this c value, you can choose the points. Okay, when x is 0, y value is 4. When x is 1, it is 5. And when x is 2, it is 8, somewhere here. And when x is minus 1, it is minus 5. And when x is minus 2, it is 8, like this. So the graph goes something like this. It will never touch x-axis and it will never intersect x-axis also. X-axis is here, right? So at minus 4, y value, when x is 0, y value is minus 4, but y is never becoming 0. Therefore, in this case, you can say it has got no zeros or no 0. Okay, you can check it out. You know how to find the zeros of the polynomial. Let us take a polynomial as x square plus 4. We equate it to 0, so that x square equal to minus 4. Can you find the negative root of negative number? You cannot, right? Therefore, no 0. It's not intersecting x-axis. Therefore, you can say it has got no 0. Okay, let us look at the third case. For that, I have a polynomial, quadratic polynomial, y equal to x square minus 4x plus 4. First, make a table by giving different values to x and y. Okay, I got the table for x and y values. Okay, so you're getting only one point where the y value is becoming 0. Let me draw this. When x is 0, y value is 4, somewhere here. When x is 1, value of y is 1. When x is minus 1, value is 9. When x is minus 1, value is 9, say somewhere here. And then when x is 2, value of y is 0, right? And when x is minus 2, it is 16, okay? And when x is 3, value of y is 1. So we'll drop it goes something like this. Upper parabola again, because a is greater than 0. So you can look at here, you can observe it is intersecting or touching x-axis at exactly one point where the value of x is 2. So it has got only 1 0, or in fact we say two zeros are equal. Okay, 1 0 or two equal zeros. You can solve and check it out. So you know x square minus 4x plus 4. I'll just tell you. Equate it to 0. Polynomial is x square minus 4x plus 4. To get the zeros, equate it to 0. You know this can be written x square minus 2x plus 4 equal to 0. Factorize them. Can take x common, so that x minus 2. Here you can take 2 common, so that x minus 2 equated to 0. So x minus 2 into x minus 2 equated to 0. This is same as writing x minus 2 equal to 0. X equal to 2 is the 0 of the polynomial, and since it is occurring twice, you can say zeros of the polynomials are same, that is x equal to 2. So this is the case you are having a quadratic polynomial. Now what happens if you have a cubic polynomial? So let us look at it. Cubic polynomial. What is the general form of a cubic polynomial? You can write ax cube plus bx square plus cx plus d, where a is not equal to 0. It's a general form of a cubic polynomial. Here again 3 cases. Okay, one case is when you draw a polynomial p of x is equal to x cube, you are getting only 1 0. And if you have only 2 terms like that, then you will get 2 zeros, and sometimes you will get 3 zeros. Okay, but at the most you can get 3 zeros, because this polynomial is of degree 3. So at most you can get 3 zeros. Okay, so I'll explain you this with example. Case 1, for example, I'm taking simple example, p of x equal to x cube. First you make the table x and y values. When x is 0, y is 0. When x is minus 1, y is also minus 1. When x is 1, y is 1. x2, y 8, and x is minus 2, y is minus 8. How the graph will be? X-axis, y-axis. Okay, x is 0, y is also 0. When x is 1, y is 1. You can cross check, okay? You draw, then you'll understand better. X is 0, y is 0, x is 1, y is 1. When x is 2, y is 8, say somewhere here, I'll point out. When x is minus 1, it is minus 1. Here. When x is minus 2, it is 8, say somewhere here. Okay. So when I join the points, it comes out to be something like this. something like this. Okay. In this case, you can observe that it is touching x-axis exactly at one point where x value is also 0, right? So this polynomial has only 1 0, okay? 1 0, that is x equal to 0 is the 0 of the polynomial. This is first case. Let's look at the second case. For that, I am taking a polynomial p of x equal to x cube minus x square. See, this can be rewritten as, if I take out x square outside, then I am getting x minus 1. Okay, now make a table, x values and y values. When x is 0, y is 0. When x is 1, again y is 0. When x is minus 1, y is becoming minus 2. Just look at this. Roughly I am drawing, okay? When x is 0, y is 0. When x is 1, again y value is 0. When x is minus 1, this is the case, minus 1, y value is minus 2, somewhere here. So what happens is, minus 1 to 0, it's increasing. It's increasing and it's becoming 0. Okay, from 0 to 1, okay, at 1 it is 0, but from 0 to 1 it will decrease, okay? It decreases and then again increases and it becomes 0 and it goes up like this, okay? So this graph is like this. It is intersecting x-axis at 2 points. One is here and another one is here. So 2 zeros you have got. 2 zeros, that is x equal to 0 and x equal to 1. The last case, for that I am taking an example, p of x equal to x cube minus 4x. I have a table for the polynomial x cube minus 4x. This is my table. I will draw. Okay, now when x is 0, value of y is 0. When x is 1, y is minus 3, somewhere here. Okay, when x is 1. When x is minus 1, it is 3. When x is 2, value is 0. When x is minus 2, y value is 0. So curve goes something like this. Not a straight line, okay? Okay, this is the curve. Here it is intersecting x-axis at 3 points. One is minus 2, another one is 0, and the third one is 2. So you can say the polynomial x cube minus 4x has got 3 zeros. They are x equal to 0, x equal to 2 and x equal to minus 2. You can always cross check by equating it to 0 and find out the zeros of the polynomial. Just by looking at the graph of the polynomial, you can make out how many zeros it has got and what are the zeros. Okay. Therefore, in general, see, this is for the cubic polynomial. So we studied 3 types of polynomial. how we explain in general. In general, if you have a polynomial of degree n, okay, degree n, then that polynomial can have at most n zeros. At most n zeros, okay, means at most n points the graph of this polynomial intersects x-axis, okay. Therefore, you can say polynomial p of x of degree n has at most n zeros, okay. I have few problems for you. You just write down. Let me know how many zeros this graphs has. Okay, I'm representing few polynomials in graphs, and you check out how many zeros the graph has. In fact, the polynomial has. Okay. See, this is my polynomial p of x. This is x-axis and this is y-axis. This is the curve or a polynomial. I'm representing it by a straight line. You tell me how many zeros it has. And the second graph, I have something like this. X-axis, this is y-axis. Okay, I have graph something like this. Goes up like this. Tell me how many. This is my graph of p of x. The third one. This is my polynomial p of x. Sometimes the curve of any polynomial, it just touches the x-axis. Sometimes it intersects. Okay, you tell me how many zeros of these polynomials has. Okay, try it out. In my next video, I'm just telling you about the relationship between the zeros and the coefficients of a polynomial. Thank you.